Today, we're going to talk about one of the most frustrating things about AI right now. It's absolutely terrible memory. But we're also going to look at a new system called LightMem, which is a huge breakthrough that promises to fix it, giving AI a memory that's not just bigger, but way, way smarter. All right, let's get into it.
So, you know the feeling, right? You're using a chatbot, you're deep in a conversation, you're explaining your project, maybe you mention your dog's name, and everything's going great. And then, 5 minutes later, poof, the AI has absolutely no idea what you were just talking about. It's like you're talking to someone with amnesia. And this isn't just some minor bug. It's a fundamental problem for pretty much all of AI.
So this forgetfulness has a name. It's called the context window problem. You can think of it like the AI has a tiny little sticky note. It can only write down so much information at one time, and as soon as that note is full, the oldest stuff just gets wiped away to make room for the new stuff. The AI isn't trying to forget, its whole design basically forces it to. So how do you solve this super high-tech digital problem? Well, the researchers behind this breakthrough didn't look to faster computers or fancier code. Nope, they looked at the best memory system ever designed, the one that's right inside your own head. They decided to model the AI's memory directly on the human brain. The specific model they used is called the Atkinson-Shiffrin model. Now, this isn't some newfangled idea. It's a classic theory from way back in the 1960s, and the core idea is simple but powerful. Our memory isn't just one giant storage bin. It's a really sophisticated three-stage pipeline that filters, processes, and then stores information.
And here's how it works for you, every single second of every day. First, you have sensory memory. That's just a super brief buffer that catches everything. Sights, sounds, you name it. Then, only the important stuff moves into your short-term memory, which is like your brain's active workspace. And finally, the really critical details get locked away and stored in your long-term memory. It's simple, it's elegant, and it's ridiculously effective.
And this right here is the absolute genius of the LightMem system. The creators didn't just get inspired by the idea, they literally built a software version of this exact three-stage model. They created a digital memory pipeline for the AI that perfectly mimics the flow of our own minds.
Okay, so how does this actually work in code? Let's pop the hood on the LightMem system and look at its three main parts, because you'll see how they map perfectly to that human memory model we just talked about. I mean, the parallel here is just crystal clear, isn't it? Light 1 is the AI's sensory memory. It takes in all the raw data and immediately filters out the junk and compresses what's left. Light 2 is the short-term memory. It organizes that important info into useful summaries. And then there's Light 3, the long-term memory, which uses this really clever offline process to store everything permanently. Let's dig in just a little deeper. Light 1 is super smart about identifying what's important, these little bits of data we call tokens, and it just throws out the rest. Then, Light 2 takes that essential data and basically builds a little library, so everything's structured and easy to find later. But you know, the coolest part for me is Light 3. It updates its main memory storage offline during sleep time process. It's exactly like how our own brains process the day and consolidate memories while we sleep. This lets the AI learn and remember new things without slowing down its performance at all. Okay, that all sounds great on paper, but does it actually work? Well, the performance numbers they got are not just good, they are absolutely staggering. This is not a small step forward, it is a giant leap. First, let's talk efficiency. LightMem cuts down the amount of data the AI needs to handle by up to 117 times. That is huge. It makes the entire system incredibly lightweight, which saves a ton of computing power and money. And that makes this kind of powerful AI way more accessible for everyone. And next up is speed. Because it's juggling so much less data, the system runs over 12 times faster. For you, that means less waiting for an answer. It means conversations with AI that actually feel natural and fluid, not clunky and slow. But here's the real kicker. Usually when you make something way faster, you have to sacrifice some quality. You have to cut corners. Not here. LightMem actually improves the AI's accuracy by almost 11%. So let's get this straight. It's faster, it's cheaper to run, and it's smarter. That is the holy grail. So look, a faster, smarter AI memory is obviously a massive technical win. That's clear. But the real story here, the bigger picture, is all about how this breakthrough came to be and what it means for the future of innovation itself. This is so important. The LightMem project isn't locked away in some corporate lab. It's completely open source. The code is on GitHub right now for anyone in the world to download, to use, and to improve upon. That decision, to share this technology freely, is what turns a cool project into a true game changer for the entire field. And the research paper itself, it was published on arXiv. That's an open server where scientists can share their work the second it's ready. There are no long waits for traditional journals. It's all about getting these ideas out into the world as fast as humanly possible.
And this really shows you the new engine that's driving AI. The old way was secret labs and slow, isolated progress. But the new way? A breakthrough like LightMem gets published on arXiv, the code goes up on GitHub, and literally within hours, a global community of developers can be testing it, finding bugs, and building new things on top of it. This is exactly why AI is moving at lightning speed.
LightMem really is a huge step toward an AI with a perfect human-like memory. One that remembers every single detail of every conversation we've ever had with it. And as we get closer and closer to perfecting this art of remembering, it leaves us with a really fascinating and pretty important question. What are the things we're going to want